Am I audible, Dr. Jeffrey Koperski? I'm really thankful that you've joined us on time, in fact, ahead of time. I'm Dr. Umar Farooq Said, who coordinated with you. And I would now like to invite you for your speech, for your keynote speech, to begin this prestigious conference. You have the topic of philosophy of science, but I would really like to know more about your book, Divine Action and Determinism on Divine Providence, and the things you would like to share with us.
All right. Well, hello from Michigan. I know it's early there, but it's late here. So if you promise not to fall asleep, I'll do the same. All right. Well, I'll start from the top again. So let me say hello from Michigan for those of you who couldn't hear that before. I know it's very early there. It is late here. This is past my bedtime. So if you will promise not to fall asleep, then I will do the same. So I have been asked to speak about something in the philosophy of science. That's my area of specialization. And one topic that I've been talking a lot about is the laws of nature. So you might think that there really can't be all that much to talk about because you know some of the laws of nature, and middle school children know a few of the laws of nature. So why would I choose to talk about something that's so common? Well, it's because the question is not what are the laws in, say, chemistry. The question here is, what is a law of nature? Okay, are they out there? Are the laws governing the universe in some sense, or is the notion of law just a kind of figure of speech? That's what I want to talk about today. So, again, what kind of thing is a law? All right. So let's get to it. There are three main views when it comes to thinking about the laws in the philosophy of science literature. I'm going to introduce them real quickly, and then I'll go back over the details. So the first of the three takes laws to just be repeating sequences of events. So we observe things like the regular orbits of the planets, and then we summarize that data in something like Kepler's laws. The regularity on this view of the orbits, that just is the law. That's it. So this approach is called a Humean view of the laws of nature after the philosopher David Hume. And the Humean denies that the laws in any way govern reality. They just are. The laws just are summaries of what we observe. So this is a very minimalist understanding of the laws. The second of the three says, well, no, look, there are things that control events. It's just that the second view doesn't believe it's the laws of nature that control events. The laws are not responsible for the regularities in nature, they say. It's instead something internal to things themselves. And these internal things are sometimes called dispositions or causal powers. The third view are the folks that believe that the laws themselves are a kind of fundamental category in reality. We'll call these people nomological realists. Nomological realists. So nomos there is the Greek root for law, and then realism means that in some sense the laws are real. They are out there to be discovered. So I'm going to give you three broad families: Humeans, dispositionalists, and then the nomological realists. And there's actually a lot of diversity in each of those groups, but I hope to give you just enough of the detail that you can see some of the strengths and weaknesses in each one. All right, so let's start from the top then, the Humean view of laws. I think most philosophers of science hold this view, as far as I can tell. I think it's because many of us don't like metaphysics. I do, but I'm an exception. Humeans believe in occurrent events. So like if you close the door, that's a change from open to closed, and that change, that's an event. At the same time, Humeans reject the idea that the laws in some sense govern reality, because on their view, nothing governs reality. There is no sense in which nature has to behave in one way rather than another. That's, again, according to the Humean. So all the laws of nature are, on their view, is again a regular sequence of events. So the temperature drops below 0 degrees and water freezes. And you see that happen again and again and again. So eventually we come to the realization that it's a law of nature that when the temperature drops, water freezes. Now that's a very simple form of Humeanism. It's called regularity theory. But most humans, even today, have given up that view. And that's because it turns out it's very hard to specify which regularities should count as laws. So all electrons have negative charge. That sounds like a law. All the pens on my desk have blue ink. That does not sound like a law. The problem is that both of those statements have the same logical form. So you might think, well, we should be able to come up with a few conditions to be able to say, well, which of those counts as a law. But it turns out it is really hard to do. The conditions you come up with will either include regularities that we don't think should be laws, or you're going to leave out some regularities that really do look like laws. So most humans today have given up that kind of simple regularity approach. So today, the standard Humean approach is something like this. It's called a best systems view. So here's the idea. So let's say that reality, the whole of reality, is made up of individual events, like a spark starting a fire. And so we take all these events and put them together. They call that group the Humean mosaic, individual tiles that make up the big picture. And each tile is one event, one change. Now, say we had one true sentence for each of those events. Now, it's going to be a lot of sentences, right? Because there's a lot of events in reality. And say now we organize these truths into a deductive system that will allow us to derive as many facts as possible from one set, hopefully a small set of axioms. So it's kind of like Euclidean geometry, right? You start with a set of axioms, and then you try to derive a bunch of truths from those axioms. That's the kind of thing that they're after here. All right, so finally, if we've got a few different deductive systems out there that we can choose from, we're going to choose the one that gives us as many truths as possible, allows us to derive as many truths as possible, and that's simple enough for us to use. So on this best systems Humean view, the axioms in that deductive system are the laws of nature. The laws are propositions that organize all the facts, because that's what laws do, says the Humean. The laws don't regulate, they don't govern events, they aren't out there to be discovered, they're just a special set of propositions. So for a hardcore empiricist, this is great, because all you need to believe in is the Humean mosaic of events. So if you're skeptical about metaphysics, this is your view. This is what you want to believe. Now, some of you feel dissatisfied with that view because you think, well, no, I think, don't the laws actually govern reality in some sense? Isn't that what they do? Some of you just think that they can't just be a set of propositions or equations. And I think your intuition here is right. There's an important ambiguity in the phrase law of nature. Okay, so not everyone in the conversation is talking about the same thing. So let me make a really important distinction. There are laws, and there are law statements. Okay, so a law statement, that's the kind of thing you find in like a physics classroom, something you could write on a whiteboard, okay, like the ideal gas law. Law statement. The laws themselves, if there are any, are the actual laws of nature that are out there that scientists are trying to discover. So the laws themselves, they can't be wrong. They just are whatever they happen to be. Law statements, the things in the textbooks, well, those are descriptions of laws. If a law statement is true, it's a law of nature that makes it true. So while gravity has been around for billions of years, Newton's equation that describes gravity has not been around all that long. Okay, so if you understand the distinction, the key to understanding Humean laws is this. There are no laws of nature. There are only law statements. Those axioms in the best systems approach are law statements. So if you don't like this view, it's because you think there's got to be more to the story than just equations in a book. And the Humean would say, you just need to get over that because there are no laws of nature. Now, those of us who are not Humeans believe that they've given us just half an answer. Because what we want to know is why? Why does nature have these regularities? Why don't electrons ever attract each other? Why does gravity work the same way here as it does in other galaxies? Why, in short, is nature so often regular and uniform? And again, the human will try to tell you just should not ask those sorts of questions. But if you think those are perfectly good questions and that they deserve an answer, then you're going to need a different account of laws. So non-humans, the rest of us, agree that there are answers to these questions. When a law statement is true, there's something that makes it true. There's something that keeps nature running on course. I should say the main reason that I'm not a human is that this best systems approach, it makes the laws depend on us. The best deductive system that we're supposed to choose here is determined by our preferences, things like simplicity. That's something we value, but I don't think the laws of nature should depend on our preferences. And, say in 500 years, our preferences change. Say instead of simplicity, all we care about are maybe successful predictions. Well, in that case, what counts as the best system would change. And if the best system changes, then the laws of nature would change. And that sounds awfully odd, right? That makes the laws sound like a social construct, something that depends on us rather than something that scientists have to work hard to discover. So again, I'm not a human about the laws. Okay, so let's move to the second view then, dispositionalism. This one says that there is something that out there that in nature that keeps nature itself uniform, but it denies that that's the laws of nature that do that. What accounts for the regularities we see are the causal powers or dispositions within each thing. So let's take something like salt. The dispositionalists would say that salt molecules have lots of dispositions. They have the disposition to dissolve in water. They have the disposition to attract other bits of matter by way of gravitation and a lot more. So on this view, every entity has lots of dispositions to act in the right conditions. So, and if you know anything about the history of philosophy, dispositions might sound a lot like Aristotelian essences. And if so, then you're right. Dispositionalism is the philosophical descendant of Aristotelianism. So dispositions in this view, they are active powers in nature. They ensure that things behave in the right ways. So while the Humean can't guarantee that electrons will never start attracting each other, a dispositionalist can. Dispositions don't change. So not only do electrons not attract each other, they cannot do so. Their disposition to repel cannot change. Now, so if you think there's more to the laws of nature than just law statements, then this is a step in the right direction. But it's only a step, in my opinion. This is a very popular view, dispositionalism. It's a popular view among metaphysicians and philosophers of religion. It's somewhat less popular among philosophers of science. And one problem is it doesn't fit very well with the history of science. Scientists like Isaac Newton and Robert Boyle rejected dispositionalism in favor of the next view that we're going to talk about. And the shift from Aristotelianism to a law-centric view, the shift is very important in the scientific revolution. And I don't have time to explain why that is. You can ask me later if you want. But it was an important change. Another problem, another reason I don't favor dispositionalism, it doesn't fit well with all the laws of nature that we know about. So things like conservation laws, like conservation of energy, those put restrictions on change. They don't cause change the way that dispositions are supposed to. So I don't think dispositions can account for all the different types of laws that science has discovered. Okay, we're moving fast, I know. There's one option left. Nomological realism. So the realists believes that the laws have their own kind of metaphysical standing, that the laws are what law statements are trying to describe. So if a law statement then is true, it's because there is a law of nature out there that makes it true. And I think, you can tell me if I'm wrong, but I think this is what most people have in mind when they hear the phrase law of nature. Okay, so the laws are real, but what are they? I mean, what's the ontology here? Well, You won't like the first option, okay? But this is the one that philosophers are most familiar with. So I'm going to run through it real fast. So let's consider a law statement. All metals conduct electricity. All metals conduct electricity. That's true. What makes it true? Well, on this first type of nomological realism, the terms metal and conductor refer to universals or properties. And when one property necessitates another, which just means that if one property occurs, the other one has to occur, then there's a law of nature at work. So if a thing is a metal, then it has to be a conductor. A law of nature in this view is just a particular relation between properties. Okay. Now, I don't know, maybe that sounds completely trivial to you, but there's a lot that's packed into this notion of universals. Universals, they aren't just sets of things. So like all my coffee mugs, it's a set, okay? That's not a universal, it's just a group of things. And universals aren't individual things. So you aren't a universal, and my laptop isn't a universal. A universal is a property that can be in more than one place at a time. So my coffee mug is red. The pen I use for grading is red. So redness shows up in more than one place at one time. It's the kind of thing that philosophers call an abstract object. Okay? And so some people believe, this first view, that when universals are related in just the right way, you get a law of nature. Okay? Now, if you're an empirically minded person, you're probably not too happy with all this. I mean, it's all so abstract and philosophical. I get that. Okay, and if you have a background in science, this just you might have trouble connecting anything I've just said here to the laws that you're familiar with, and I get that too. I mean, you know what a metal is, you know what a conductor is. What are these abstract objects, right? How do we know about those sorts of things? I think those are good questions. I'm not going to try to answer those questions because I don't think there are good answers to those questions. Look, I'm a nomological realist. I think that's the best approach, just not this type of nomological realism. Relations between universals, necessitation. Okay, I don't know. Let's try something else. Okay, so someone like philosopher Tim Maudlin has said, look, the idea that there are laws of nature is so important and so useful, we should just start there. So instead of trying to explain the laws in terms of universals or anything else, we should just take them as basic. We should just accept that there are laws of nature and just forget about giving them any sort of analysis. Just take them as basic building blocks of our overall conceptual scheme. Don't try to analyze them at all. Now, you might feel like that's cheating, okay? Because it seems like we could do that with anything, right? But Maudlin is right about one thing. We all have to start somewhere, right? At some level, we all have fundamental assumptions about what reality is like. So you probably believe that causes always happen before their effects. You probably believe that you're not the only conscious being on the planet, okay? But you can't prove either of those. So there's just no getting around the fact that you can't have evidence for everything that you believe. So given all that, Maudlin thinks that we should just accept the idea of laws of nature as foundational. Just take it. There are laws of nature. Now, again, if you think it's cheating, I get that. Okay, let me tell you what I like about it. Okay. First, I agree that the idea of laws is really important. So this is one reason I'm not a dispositionalist, because they try to replace laws with dispositions. But I also think that the Humean notion of law is too weak. So like all nomological realists, I think there are laws of nature out there, not just law statements in textbooks. But I don't think we have to take them as basic. I think we can say more. So let's start with a different question. Where did this notion of laws come from in the first place? And the answer is theism. The leading thinkers at the time of the scientific revolution were all theists. Okay? So most thought that the laws of nature were just patterns within God's will for how nature must behave. So God just decreed how things would go, and that's how they go. right? Electrons always track protons. Light always moves at 3 times 10 to the 8th meters per second, and on and on and on. The laws of nature are God's decrees. Now, that's obviously very different from how we think about laws today, because when we teach science or the history of science, there's seldom any mention of God. In fact, we often treat them as competing explanations, as if once we explain something according to the laws of nature, we don't need God anymore. Now, 17th century thinkers would have been utterly confused by that sort of tension. They would have said, look, you can't have laws for the whole of nature without God, right? You've got to have both of those together. The idea that there's some sort of conflict between laws and theism would have been virtually unheard of until the 1800s. That's a whole story. All right, so having looked at the options, I think Newton was right. I think the laws just are God's decrees for how nature must go. The philosopher Alvin Plantinga calls this type of nomological realism decretalism. Decretalism, the laws are God's decrees. All right, now that's clearly a minority position today, right? But it has some positives. One is it's a form of nomological realism, so it's in the right camp in my view, right? It takes the laws of nature seriously. And second, decretalism is a conservative position for theists. What I mean is we already believe in God, so I don't need any additional stuff to make sense of the laws. I don't need dispositions. I don't need universals, right? So if you're not a theist, right, this doesn't work for you. I get that. That's fine. But for the rest of us, this is a live option. Okay. And then third, decretalism has history on its side. And one of the confusing things about this topic is that philosophers and scientists have been talking about the laws of nature for 300 years. So you might think that we're all talking about the same thing. We're not all talking about the same thing. When scientists like Newton and his contemporaries talked about the laws, they were thinking about them as divine decrees. Okay, doesn't mean we have to believe exactly what they did. Okay, and if there's a better view out there, if there's a better understanding of laws available, fine, I'll take it. Having looked them over carefully, I don't think there are any better views. So I'm pretty happy to adopt the understanding of laws that launched the scientific revolution. Okay, so if I'm right, why aren't there more decretalists out there? Well, as you know, most philosophers in the West are naturalists, right? So they only believe in the things studied by the natural sciences. But I do find it interesting that they have trouble doing without this notion of laws, because everyone agrees that it was originally a theological idea. The laws of nature come from a lawgiver. So I ask, if naturalism is true, it seems like it shouldn't have anything to do with the laws, right? It's kind of like saying you don't believe in unicorns, but you can't stop talking about unicorns. I think the laws are an odd fit for naturalistic science. It seems like they should come up with something on their own. All right, well, that's it. I am out of time. So this morning we have looked at 3 views of what it is to be a law of nature. You've got the Humean view, dispositionalism, and nomological realism. So the Humean view, again, I think is a bit too weak for most philosophers. We don't think that the laws are just special propositions. We don't think the laws depend on our preferences. Okay, dispositionalism is a popular view. I just don't think it fits very well with modern science. And there, in my view, nomological realism, at the end of the day, is the best of the 3. And the specific type of realism that I have defended is decretalism. All right, so I hope I've said enough in this brief talk for you to consider it. If you want more, my second book is free to download from the Routledge site. You can Google Koperski and Routledge, and it will take you there. Thank you very much.